Wednesday, January 14th, gonna cover lesson 7.5 with you guys, modeling data. A lot of this has to do with tables and scatter plots. So you see in your book, I see lots of tables of data. There's some, yeah, here we go, like some scatter plot looking graphs here. Can you fit a line best fit? Which we actually did last semester. Desmos will create curves best fit. So I'm gonna do 5 examples with you guys, remind you guys how to do that. All right, so we're going to shift the timeline a little bit, the schedule here. I'm going to do a Kahoot review with you guys, Module 7 tomorrow. Okay, and then let's have Friday be an Alex Day. And you guys are thinking about these 3 assignments, which are upcoming due. So 7.1, 7.2, 7.3, that's a single assignment. And then 7.4, 7.5, that's a separate assignment. Okay. I went ahead and bumped the due dates to Tuesday. So you have a few more days to work on those. And then don't forget also, Alex 70% Pi goal is due on March 11th, so you can work towards that if once you've knocked out these assignments. Okay? Okay, and then let's move the Module 7 quiz to Tuesday. All right. So let's put this modeling data here. So we got these tables of data. All right. I'm going to do 5 examples with you guys. So I'll do these 3, and here the premise is out of these tables of data, would they best be modeled by something that's linear, quadratic, or exponential? Right? Now, since the theme of this module looks like it's had to do with exponentials, I'm sure one of these will be exponential. Right? So I wonder which one that is and how do you model that? Right? And then there's a couple of story examples too. I think I picked out these 2, have the data ready to go. All right, so let's take a look. All right, so if I go to Desmos here, can open up Desmos, open graphing calculator, and then type the word table, T-A-B-L. And as soon as I hit E, bam, it opens up a table. Then I can just start punching numbers in, right, for X and for Y. Right now I have some of the data put in already. Right, so one of the stories, I think one of the first 3 stories, we get this data. Oh, I better zoom in a little bit here. Let me zoom in. It's easier to see. All right, yeah, that's better. Okay. All right, so I've got these x values, y values. Now, the first 3 examples didn't have a story attached to them, so I don't know what x and y represent. But you can see on the graph that, oh yeah, all these points line up. It looks pretty well a straight line. I think a straight line would model that really well. All right, so how can I model a straight line? Go down here to 2, type y_1, and then right arrow key. Then you need the tilde, so shift tilde. Okay. Now, somebody with mx plus b. And for the constants, I'll call them A and B. So I'll do A times x_1, right arrow key, plus B. Okay. Ah, that line of best fit fits really nice through that data. Yeah. Yeah. Right, so then uh, Desmos behind the scenes does a really fancy statistics, runs a fancy statistics model and comes up with like perfect values for A and B, or as close as you can get. Right? Like it could best match that data. All right, so we got that. Let's look at some other examples. All right, so another one in the book. Right. Oh, right. So again, I've plugged in the data ahead of time just to save us a little time here. Right. So I've got these x values, these y values, and here's what the scatter. Whoops. Right. Here's the scatter plot. Right. So I can scroll with the mouse wheel and kind of scroll around a little bit. Right. Yeah. Right. Now, earlier today with one of my classes, I was thinking, oh, that looks like it maybe wants to be a cubic or something. I tried to fit a cubic to this. It didn't really work at all. But then I went back to the premise and it kind of narrowed it down to either linear, quadratic, or exponential. So let's go quadratic. Right? Maybe an upside down parabola might fit that fairly well. So y_1, right arrow key, tilde, and then a parabola. That's somebody with like ax squared. Right? So a couple ways I could do this. I could do a x_1 and then right arrow key squared. Okay. Now, if I assume that this is centered on the y-axis, I can just say plus b, bam, right? Yeah, that's a pretty good fit right there. In fact, that might be plenty sufficient, right? I might be able to get a little bit more precise. Let me see what changes if I add one more term. What if I do, call this bx and plus c? Whoops, gotta do _1. There you go. That's better. Okay. Yeah. See how b is very, very, very close to 0? It's like if I left that off, you just went like x squared plus b or x squared plus c, then that would probably be pretty close, right? This makes it a little bit better, right? Alternatively, you could do let me show you guys just a different way to also write this. Okay. Let me clear
some of this out. Okay. What if I do a multiplied by, and then in parentheses, x underscore one, and then write okay. Let's say minus b. Ooh, like I'm shifting it. Right? And then I'll do squared, right? And then plus c, like that. Right. And this should be the exact same parabola shape as I got before, but I wrote the equation a little bit differently, so got a little bit different numbers. Right. So there's a couple of ways to do that one. All right, next example. All right. So I think this is again, this is one of the first three. I don't know the exact order. Okay. But I plugged it on the table data. So this is straight out of your book on page 41. Okay. And look at the scatter plot data. Well, I think this is the one they probably intend to be exponential. See, it looks like it's maybe kind of flat down here and then it takes off real steep. Yeah, let's assume this is exponential. How could you model that? So I'll go down here. I'll say y underscore one is proportional to so tilde. Um, okay, I need maybe some leading coefficient and then some base to a power of x. Right, different ways to do that. I'm going to try this. Let's do a times. How about let me try e. I'm going to see what happens with e. E to the power of x underscore one. Okay, that maybe looks okay. Right. What if I change this e to some other base? Okay, if I change the e to some other base, it does pick a more effective base for me. That curve does look a little bit better. It gave me something a little different, right? What if I change this to e, back to e, right, like the natural base, and I change this to like c times x? Yeah, is that the same curve as I got when I just left this as b? Right? I think you could, like e to the c could effectively create a different base value, right? Something like before. Here, I'll do this one more time. All right, so good look at that curve, exactly where that is. I'm going to subtract this out and replace this e with some generic b. And yeah, I think it looks the same as when I put okay, right? Because there's different ways to go about this, right? But yeah, that looks like a pretty good curve best fit. All right, now these next two did have stories attached to them. Okay, so drag this one over. Let's see what data is this. This is the one, say, going 0 to 10 and look at that. Oh, okay, I know what story this is. Okay, and I'll point it out to you guys. Okay, so this is this data, this table right here, I just got copied. Okay. So the story is Brittany deposits $1,000 into account. So at time zero, she has $1,000. That's the principal. Okay. And then it looks like her money is growing, and every 2 years she's checking in. Okay, so the money's growing. So this has got to be an exponential curve. Right? And there's again a few different ways to craft that. And I just showed you guys a couple ways. Right? So what can we do with that? Right. So back over here. Right. Now, oh, I should say too, these points might not land exactly on the curve because maybe sometimes she's taking out a few dollars or she's putting in a few extra dollars. Right. Or maybe for that matter, the interest rate fluctuates a little bit. I mean, that could be reasonable too. Right. But maybe an exponential curve could approximate it. Now, one thing is, I don't even see the dots. Where did all the dots go? But look at the numbers really carefully. X goes 0 to 10. Okay, that's in the frame. But the Y value is up in the thousands. So I'm going to go over to this wrench tool. And for the x-axis, well, I guess I could just leave that alone. That's fine. Okay. But the y-axis, I need to take all the way to, let's pop in 2000. All right, so now the points should be in frame. There they are. Right, and then I can, with my mouse wheel, still scroll around a little bit. Yeah, that looks framed a lot better than before. Right, and yeah, do you guys see how it does look like these points are kind of curving up-ish? So this should be an exponential. Right. So I remember, here, let me go real generic. Do you guys remember like the amount as a function of time could be equal to the principal times one plus the interest rate all to the power of however much time has passed, right? Like if, for example, if the interest rate was 5%, everything in parentheses is 1.05, and at the end of every year, you're effectively multiplying your money by 1.05, right? And keep doing that over and over and over. Okay. So there, that's why this is an exponential t, because you keep multiplying 1.05 over and over and over. Right? Okay, now I left that really generic, but how could I get this equation to model this scatter plot? So in place of a, I'm going to call that y, so it matches my graph. Right? For the principal, I'll go ahead and plug that in as 1,000 because I do see that would make sense. That has to be 1,000. Right? Now, what is the interest rate? Well, I don't know right away. In fact, I'll let Desmos figure that out. And this t represents time. Now, a couple ways I can handle that. Because right now this axis is reading as an x-axis. So I can either change this to x and do x sub 1. Actually, that's what I'm going to do. X sub 1 up here. Right. Oh, what just 1 plus interest rate. Right. Oh, I know what. Okay, I have to do y underscore one. Oops. Okay, forgot that. Y underscore. Oh, okay. Hold on. It just got rid of all my data. Yeah. Let me pause this and pop that data in real fast. All right, let's try this again. All right, so I forgot to sometimes it mess up. So y underscore one. If you forget the underscore one, then sometimes it'll mess up. All right, so that's okay. We're back on track. All right, so the principal, I'll call 1,000 because that makes sense to the story. And then times one plus the interest rate, I'll call that R, and I'll let Desmos figure out what that is. That's the power of, and then, well, my time axis is the x-axis, so I'll do x underscore one. There we go. All right, that's a nice looking curve. Yeah, that is an exponential curve that fits that data right there. That is it. That's fine. I wonder what the interest rate is. Well, let's see what R is. And you can see it right here. R is 0.0435 something. So I think the interest rate is about 4.35%. Yeah, yeah. Okay. And since these points don't land exactly on the curve, she's either taking out some money in the beginning and then maybe putting a little extra in at the end, or maybe the interest rate is fluctuating. Maybe it started out at about 4.3%, and maybe it dropped down to like 4.0, and then maybe it bumped up to like 5%. It could be fluctuating interest rate, right? But yeah, it looks pretty well. It's exponential, right? Okay, and let's do one more story here. I'm going to drag this window into frame. Okay, so I have some data here, but what is this data? Okay, so right back over here. Okay, so I think that's this table right here, exactly where I got it from. Here's X values, Y values. Ah, a survey of how much time did you spend studying for the exam in hours? That's this X-axis column, X column. And then what grade did you score on the exam? Ah, right. What do you guys think the correlation is going to be? Let's see if I study more hours, how am I going to do on the exam? Right. Well, let's see what the scatter plot looks like. Right, now, kind of like the last question, I don't see any of the points here, even though I have all the data plugged in. Right? Where's all my points? So I'm going to reframe this. Now, looks like my largest X value is 8. Okay, so that's already in frame. Right? Maybe I can slide this around a little bit, but that's already in frame. But my Y values go up to, oh, hey, ooh, I see a 96 up there. Let's take that to at least 100. So let's go to the Y-axis, take this to 100. And then that should put all the points in frame. There we go. That looks a lot nicer. Yeah, yeah, yeah. Right. Right. And I see a positive correlation. So it looks like the more hours you spent studying for the exam, the higher the grade you got. It looks like the kid who spent the most hours studying got the highest grade. That's right. One thing you'll hear Principal Legate say over and over, her say this many times on her announcements on Friday is uh, what's more effective way to study? Right. So I would ask you guys in class, would it be better? Suppose you only have 2 hours to study. Would it be better to study for 2 hours the night before the exam, or would it be better to spread it out and do half an hour a day for 4 days? It's the same amount of time total, right? And what's more effective, just for a human brain, is to spread out your studying, see a little bit at a time more often, right? And then you'll actually remember more. All right, so that's kind of a side thought, though. All right, so let's go to this data. How can I model this? This looks like pretty well a straight line. I think I could do a straight line regression. Let's do y equals mx plus b. So y underscore 1, and then tilde. For the slope, I wonder if I do m for slope, if it'll recognize that. All right, times x underscore 1. Yeah, okay, it did, but then I got to do this plus b. Y equals mx plus b. Exactly. There you go. Right, so we got a slope and a y-intercept. Okay. Uh, you know what else I could totally see your book asking, or Alex asking for that matter, is how do you interpret these numbers? How do they match to the story? Remember, this has to do with what's your exam score as a function of the hours you studied. So I think this plus b, that aligns with 0 hours of study. So if you didn't study at all, then you should expect to get approximately a 45 on the exam, right? That's what that y-intercept means, right? And the slope tells you how effective studying is, right? So like if you put in an hour of studying, your exam score should increase by, about 6.5 points. If you do 2 hours of studying, you should expect to increase your exam score by almost 13 points. You guys that, and so on. Okay. So every additional hour of studying gets you more than 6 points on their exam, right? All right, so there you go. There's a quick rundown, regression, right? Right, how you can create regressions with all these curves here. All right, and finally back to here's the agenda we're doing, and yeah, hope you guys essentially have a good 3-day weekend and get ready for this quiz on Tuesday.